So before I get into the sharing of this new charging requirements, I'd like to take a moment to speak briefly about Delta, so that it's probably easier for everyone to know where I'm coming from. So Delta Electronics has been around for almost 50 years, starting out as a suppliers for power supplies for different applications. And in the past few decades, Delta has transformed into a solution-based global technology company. So Delta has been a proud member of the Dow Jones Sustainability Index for the dedication on corporate responsibility. And in the meantime, it's also participation in the Carbon Disclosure Project. So with all these focuses, the solutions that Delta Group is working on, including EV charging and renewable energies, among others. So today, I would like to share the view from Delta Electronics regarding the new requirements for the next generation charging infrastructure. The reason to share this is because we understand that it takes basically the full industry to move the overall e-mobility trend. So we are very happy to work with partners or customers or any other collaboration opportunities to make the future sooner. So if we look at the charging infrastructure, in general, we speak about these three major categories. There's the AC destination, there's DC destination, and also the high power charging. For AC destination charging is usually talking about a single residential home charging requirements. We have seen very much an M-shaped distribution of the requirement, meaning that on one hand side, there is like really basic charging requirements where the driver or the user just wanted to plug in the vehicle and then charging will start. But on the other hand, we have also see a growing trend to have further integration or a connected service that would allow the AC charging station to be part of a bigger picture. For DC destination charging, we talk about maybe between 1 to 4 hours of charging. So there's the location of that is more versatile. Retail, hospitality, or even business, and also fleet charging. It's let's say more or less in this category. So in this area, monetization becomes a big topic because at the end of the day, someone has to pay the bill. So to offer charging as a service and like how to make it easier to achieve that has been a very interesting topic and development in this application. So we see a lot of integration with innovative payment options, and also there's also conventional payment options, and then the integration with the metering solutions in order to really for the operators or for the site owners to monetize the charging services. And then on the right-hand side, the high-power solutions, of course, the intercity charging networks, sometimes kind of sponsored or subsidized by governments or from the public funds. Again, this also, even though the initial investment might be subsidized, but the overall operation, maintenance, service, we still has to be sustainable. So the integration with the payment, billing, the business logics are also important. If we look at the main considerations in Europe that has been collected from the Delta's market intelligence team, from the user perspective, it's mostly about the typical range anxiety And then there's also the cost of charging and also the time needed for charging. But then from the other point of view, from utility or CPO, it's usually about the grid integration or the impact to the grid and eventually how to mitigate that. And then of course, for the utilities and the CPOs, it's about the cost, right? So how to optimize the capital expenditure, how to optimize the operating expenditures. So these are very much the key topics in their minds. So I think I've also seen sharing from the other speakers earlier in this session. I think this is very much the same view of this industry. So to sum up, for the past few, let's say probably 5-6 years, we have seen the major trends in the e-mobility space. So for DC charging, we look at higher and higher power for charging. Thanks to the advancement on battery technologies, cooling technologies, now it is possible to have like a really high power charging. For example, this 300, 350 kilowatt or even higher charging. Of course, the integration with business processes would also be needed for this kind of public or commercial applications. Then for AC charging, higher power, the same. So that is related to the onboard charger on the vehicle. But then more integration with home, with the grid is also important. And then aside from the typical AC charging and DC charging, we see a lot of new movements in the V2X, in energy storage system, and also renewable energies. So the integration and also this cross sharing of application use cases, we see this become more and more interesting to the key stakeholders in this industry. And then, of course, there are innovations around that. We talk about wireless charging, autonomous charging. There are already a lot of pre-development or pilot projects, not yet fully commercialized, but that's definitely going to come up in coming years. So with the trends that we have seen, the charging stations today is mostly focusing on operation, basically. So most of the time, the charging station will be connected to a charging backend managed by charge point operators, usually, as we know, being OCPP protocol for user authentication, charging management, and also remote access. And then for the efficiency is also important because that is how to lower or to reduce the overall operating cost. And of course, the maintenance and service aspects of this operation is also important because that's also related to cost and the eventually how to achieve the highest uptime. But what is next? So from the fast growing of penetration rate of electric vehicle and now being not just passenger vehicles, but also to the bus, the truck, the fleet, we see there are going to be more and more to be asked. So we see it as we call it the efficiency leak that is moving towards smarter charging and scalable charging. By smarter charging, what we are referring to is to have the capability that to tailor the solution that's according to the actual need. That's including a lot of smarter elements, such as the integration with renewables, integration with energy storage, and all of this being put together through an energy management system. Sometimes to call something smart could be a bit subjective. So, but I think right now it's more clear that to make the charging smarter, we need these additional elements. For example, with renewable energy, we can really achieve the true zero emission transportation. That is, at the end, the ultimate goal for this next generation mobility. And then the integration with energy storage would make the overall energy usage to be more efficient, and then also with the more smooth integration with the grid. And of course, on top of that, the energy management system that will be able to manage multiple sources and in a way that would allow further applications to get into this system and to have or to create additional opportunities for integration. And of course, for the EV charging product itself, we have already spoken about this bidirectional capabilities that would allow the vehicle become one of the energy source. It could be for emergency use. It could be for power, dynamic power allocation, and to also increase the flexibility at the ecosystem. And then the other topic around EV charging is the, again, back to the efficiency. So we see, of course, the adoption of new materials like the wide bandgap semiconductors, and also the newer cooling technologies, so that it is becoming possible to achieve higher power charging, and at the same time also being high efficient. And the second important trend we are seeing is the scalability. So this is probably not the topic probably 3-5 years ago, because the number or this penetration rate of the electric vehicle is so small. So most of the people or most of the installers or the site owners are very much in this trial mode, that we'll see how it goes for the first station, and then we see how to make the second one. But as now we see more, let's say, structural deployment of, for example, the electric fleet, we want to make sure that the charging stations or charging solutions can be more scalable. So what we're showing here are the two different concepts. The first concept being a cabinet dispenser architecture that will allow a very flexible configuration of charging capability. In this scenario, just as an example, there could be a power cabinet, could be 350, 600, or even a megawatt cabinet, but connecting to multiple dispensers, where the dispenser size or the output of the dispenser can be adjusted to the need of the charging. In this example, we're talking about a fleet charging where most of the fleet, the vehicles are to be charged overnight. So maybe a smaller dispenser might be enough. But on the other hand, for emergency use, emergency charging, for some rescue service, we also provide a higher power charging. So with this flexible combination, it would be able to support different operation needs from fleet operation point of view. On the other hand, if the charging needs or the charging time is very much fixed, then our suggestion would be to cater the deployment of charging stations based on the actual vehicles, because that would be one way to really lower the hardware and installation cost. And usually for some operators who are running a more, let's say, standardized business model, this could be an interesting option because it is easier to control the overall budget and still be able to offer the kind of service needed to support their operations. So combining the smarter and more scalable missions, so we look into the energy IoT platform. So IoT is the Internet of Things is probably a overused buzzword, but in fact, if we put that into the context of energy, it's actually a perfect match because the energy infrastructure is all about heterogeneous devices and also the heterogeneous requirements. And that is simply perfect for a IoT infrastructure because this let's say the low power, low cost, while with highly dynamic, highly flexible deployment of this connectivity would be able to drive the transformation from a maybe just a smart home or a smart building to a smart city. So we have already seen several projects that is integrating like metering, the street lightings, and also the overall distribution network. So the energy IoT platform would help all these stakeholders to be able to merge the data or to have a more hierarchical view of different data stream and still be able to retrieve the most valuable information for some decision making or strategic development. So to sum up, we see a very interesting trend for the transformation from a conventional grid where this standard generation, power generation, transmission, distribution, and consumption model to a smart grid where it's all about decentralization and digitalization. So this new transformation would make the overall grid infrastructure more and more interesting and more challenging because the actors in this space now it's not just become 2 times or 3 times more. It's 10, maybe 100 times more than these conventional players. So how to utilize this the smart charging technologies and also the IoT capabilities to enable the real-time management of the system and also taking into account this integration between charging service, energy storage, and also the renewables. And for example, with this DC grid adoption, to increase the efficiency and of course to lower the operating cost. So all of this new development would definitely make EV not just as an electric vehicle, but become a very critical element in this overall system. So in the past few years, Delta is lucky enough to work with many customers and partners and to develop some of the successful cases around charging, including some of the integration with renewables or energy storage. So we look forward to working with more of you and with this different integration from different aspects and meeting different needs. Could be a typical charge park, it could be a building environment, or even a residential environment. We see that the new trends are getting into the direction where the information and also the energy efficiencies are being optimized. And we look forward to the opportunity to work with you to drive this evolution in the world of e-mobility. So this concludes my presentation. Thank you very much for your time and your attention.